So in this video, we are going to discuss about a problem on bilinear transform. So the question is, apply a bilinear transform to h of z. So h of is nothing but your unlocked transfer function. For that one, you have to convert it into h of z. h of z, h of s must be converted into h of z. So the s must be transformed to z, right? So it is a digital transfer function. So the formula for this is not to convert h of z, h of s into h of z is s is equal to 2 divided by t into 1 minus z power minus 1 divided by 1 plus z power minus 1. Okay. So you substitute in the above equation. So you know the value, they have given the t value is equal to 1. So 2 into 1 minus z power minus 1 divided by 1 plus z power minus 1. So substitute this in the above equation. So you will get the value of h of z. Okay. So the h of z is equal to 2 divided by. So instead of s, you have to substitute 2 into 1 minus z power minus 1 divided by 1 plus z power minus 1 plus 1 into 2 into 1 minus z power minus 1 divided by 1 plus z power minus 1 plus 2, right? So on solving, you will get 2. So this 2 term will goes up, right? So it becomes 1 plus z power minus 1, 1 plus z power minus 1, right? So 2, so if I bring it inside, 2 minus 2 power z power minus 1, and I am going to add this one, right? 1 plus z power minus 1. In a similar way, I can do it for this. Okay. So if I multiply with this one, I'll get 2 minus 2 into z power minus 1 plus 2 into, so if I multiply with this one, I'll get 1 plus z power minus 1. Alright. So this is nothing but 2, okay, into 1 plus z power minus 1 the whole square divide by, okay, I will get 3 minus z power minus 1 for this one if I solve, and this is 2 minus 2 into z power minus 1 plus 2 into z power minus 1. So these two get cancelled out. So we'll get 4, right? So we'll get 1 divided by 2 into 1 plus z power minus 1 power 2 divided by 3 minus z power minus 1. So this I can rewrite it as 1 plus z power minus 1 the whole square divided by 6 minus 2 into z power minus 1. Okay. Similar way, you can do it with the help of, I can convert this h of s to h of z using impulse invariant method also. So how to do it? So they have given h of s value. H of s value is nothing but 2 divided by s plus 1 into s plus 2, right? So if I apply partial fraction a divided by s plus 1 plus, so in the impulse invariant method you have to do the partial fraction method only. So so in order to find the value of a, so in this equation, so you have to remove this s plus 1 value and you have to substitute s is equal to minus 1. So since if I equate this one to 0, I will get s is equal to minus 1. So the answer is 2, right? So similar way b is equal to 2 divided by, from this equation if we remove s plus 2, because for d I have s plus 2, so I will get s plus 1. And if I equate this one to 0, denominator to 0, s is equal to minus 2. So if I substitute, I will get b is equal to minus 2. So similarly, if we substitute in this equation, we will get 2 plus 2 divided by s plus 1 minus 2 divided by s plus 2. Okay. So what is the technique is, so h of s is equal to summation k is equal to 1 to n ck divided by s minus pk. This is a format. So you have to convert this h of s to h of z by substituting ck instead of s minus pk. You have to represent as 1 minus e power pk into t is at power minus 1. So what they are mentioning is, the above equation, the h of s is nothing but, so the h of s is nothing but 2 divided by s plus 1 minus 2 divided by s plus 2, right? This is my equation. So instead of so here this I can write it as 2 divided by s minus of minus 1 minus 2 divided by s minus of minus 2, right? So the here the pk value is minus 1, right? So to represent h of z equal to 2 divided by 1 minus e power pk is minus 1 and t is 1, right? T is 1 z power minus 1. The similar way, minus 2 divided by s minus e power minus 2 z power minus 1. Okay. So what is e power minus 1? So with the help of a calculator, if you solve, you will get e power minus 1 as 0.3678 z power minus 1. Minus 2 divided by s minus e power minus 2 values 1. This is obtained. E power minus 2 values 0.1353 z power minus 1. So now you cross multiply this one. Okay, 2 into 1 minus 0.1353 z power minus 1 minus 2 into 1 minus 0.3678 z power minus 1. Divide by 1 minus 0.3678 z power minus 1 into 1 minus 0.1353 z power minus 1. So on cross multiplying this one, you will get 2 minus 0.2706 z power minus 1, right? Minus 2 plus 0.7356 z power minus 2. So minus 1. Divide by, okay, 1 minus 0.3678 z power minus 1. So if I multiply with 1, minus 0.1353 z power minus 1 plus 0.04976 z power minus 2. Okay. So on solving this one, just 2 and 2 get cancelled out. So we get 0.465 z power minus 1 divided by, and solving this one, you will get 1 minus 0.5031 z power minus 1 plus 0.04976 z power minus 2. So this is nothing but your h of z. So this is how you have to convert my Laplace transfer function into a digital transfer function. So I hope this video is useful for you. So in order to watch the other videos of digital signal processing, so you refer my playlist, which is given in the description box. So once again, I thank you for watching this video.